This video we're gonna talking about like analog and digital, and we're gonna actually using an example look at the circuit voltage dividers and photoresistor. So analog, it's continuous range of values. For example, the temperature range, from -10 to 100 degrees Celsius. That's gonna be continuous range. The temperature. Also, the digital is discrete, discontinuous value. It can be 1 or can be 0, for example. So now let's look at this input and output. Input, it's like receive the information from the external world. Output is actually deliver, transmit that information. So this is the example. Remember one of the first projects you did is give pin 7 as an output that will supply the voltage to light the LED on. So that's going to be a digital output. Okay, it's transmitting information. Now let's look at this one. Remember the switch project you did? When you have this slide switch, I mean, it's not like this, but it's similar. It's a slide switch. And then when you have a pin number 7, it's in between the switch and resistor. You have a digital read 7, and this is a read digit. That's either 0 or 1. The serial monitor will show you if it's 0, that means your switch is turned off. If it's 1, which means the switch is turned on, you have a closed circuit. So that's a digital read. It's read that information, and it's a read digit. And a new scenario here is when you have a if you're gonna read, for example, the brightness of the room, that's gonna be continuous read. That's gonna be not discrete. So that's gonna be an analog, talking about the darkness, the brightness of the home. So that's analog read. For that situation, that's ranging from 0 to 1023. It's no longer 0 or 1 anymore. When you read as 0, which means the analog, it has 0 volts. When you read out 1023, which means you get 5 volts. Okay, so higher volts corresponding the higher value of analog. 5 volts corresponding 1023. Okay, so now let's take a look at this one. Since analog pin on your Arduino is 10-bit, so that's 2 to the power of 10. That's 1024. Since we start with 0 and you're gonna end with 1023, so that's about 1024 numbers in there. Again, 0 corresponding to 0 volts, and analog 1023 corresponds to 5 volts. Knowing that, we have this proportionality formula. If you want to figure out the voltage, you can read it by using this analog read you get out from Arduino. Using that, because 5 volts corresponding to 1023, then this analog read times this ratio is going to give us the voltage, right? So that's going to be the formula you will be using. Let's look at this example. All right, so this is 5 volts, and this is a symbol for photoresistor, and this is 10 kilo ohms. Photoresistor, it changes its resistance based on its brightness, okay? And so this resistance will change. However, 10 kilo ohms is a fixed resistor. What we can do for this situation is we construct this circuit, and we have this pin gets to analog input number 4, and we read this value. If this value is read as 587, then can you figure out the voltage, right? The voltage across 10 kilo ohms and also the voltage across this photoresistor. The answer is yes. Remember the formula. Using the 587, the analog read, times 5 volts corresponding to 1023, then we know this 587 corresponding to the voltage of 2.87. That is the voltage across this 10 kilo ohms, because here is 0 volts, is ground. Right? Then here's another example. If the analog value is 324, what is going to be the voltage across 10 kilo ohms is going to be 5 volts divided by 1023, then times 324. So the voltage here is going to be 1.58. Then how about the voltage across the photoresistor? It's going to be 5 volts minus that 1.58. That gives us the voltage across here is 3.42. Okay, and of course you can also figure out the current going through using Ohm's law. It's going to be voltage divided by 10,000 ohms. That's going to be giving us in milliamps. Milliamps is 10 to the negative 3 amps. All right, so that is the circuit voltage divider. Circuit voltage divider using this photoresistor. All right, see you next time. Bye.